Hey guys, welcome back to another GCSE Maths video. This time we're doing the same things we did last time, which is we're going through the hardest questions from the November 2024 Paper 2. Honestly, in terms of difficulty, I'd say the questions are fairly difficult. One of them is a big 5 marker, which, again, once you know what you're doing isn't too bad, but a lot of students don't really know what they're doing and the wording kind of confuses them. And then we've got some probability and some other stuff to finish up with. So yeah, without further ado, let's just jump straight into it with the first question. Here's the question that has kind of odd wording. So we have this equation and they give you some rounding, and normally they'll say work out the highest or the lowest value, but here it says calculate t to a suitable degree of accuracy, which, by the way, if any of you want to go into kind of like a sciencey related field or research in the future, engineering, stuff like that, this is actually something you do on a regular basis. And it says by considering bounds, calculate the value of t to a suitable degree of accuracy. So it's hard for me to explain what to do without basically going through the question and showing you. The logic here is we're going to find the upper bound of t and the lower bound of t and see what value they both round to. And we want to make the most accurate value that we can round to. So the highest number of significant figures. So let's just kind of get on with it. So we'll try and work out the upper bound of t and the lower bound of t. In terms of where you get your marks, the good news is if you just work out any bound, so if you find the upper bound of w, or the lower bound of a, or the upper bound of c, or whatever, any bound gets you a mark. So that's pretty damn useful. So if we want to find the upper bound of t, we want to make t as big as humanly possible. We want the denominator to be as small as possible, and we want the numerator to be as big as possible. So we're going to take the upper bound of w, so I'll just mark that out. We're going to take the upper bound of w. We're going to take the lower bound of a and the upper bound of c. Why? Because if we make a really small and c really big, then a minus c is going to be a much smaller number. Same with w. If w is really big, then the overall thing is going to be quite big. The reason why we want the denominator to be as small as possible is when you divide by a smaller number, again, I used this example in one of the other videos. Let's say I have a fraction 3/7. As I make the denominator smaller, and again, you can check this on a calculator, what's happening to the overall value? It's getting bigger, right? That's the logic. And likewise, if I make the numerator bigger, so let's start with all the same denominator, let's say 5. As I'm making the numerator bigger, what's happening? Well, the overall value is getting bigger. So, the upper bound and lower bound of this, so I would probably start by working out all of the bounds for w, a, and c. So for w, it's to the nearest 5, which means it's gone from... The way I do the nearest thing is I half the value, so 5 divided by 2 is 2.5. So the upper bound is 47.5. Right, so we add that 2.5, and the lower bound is we subtract the 2.5. So again, when it says the nearest 5 or whatever, half that value and add and subtract it to this. With 9.8 to 2SF, we're actually doing the same thing. So we rounded to the nearest 0.1. So if I half 0.1, I get 0.05. By the way, this is a calculator paper, so feel free to use that. And so we're going to add 0.05, so 9.85. And we're going to subtract 0.05, so 9.75. Once again, use a calculator if you're unsure, but make sure that you can get to those values yourself. With C, once again, we've rounded to the nearest 0.1 because it's 2SF, so we've rounded to this decimal place. So half that, we get 0.05, and once again we're going to add and subtract it, so 2.55 and 2.45. So again, for the upper bound of t, we are going to take the biggest value of w, so that's 437.5. We're going to divide by the lower bound of a, so that's 9.75, and the upper bound of c, 2.55. And when I do this, I'm going to write out the exact value that I get, because I don't know what I'm going to round it to yet. So we have 437.5 over 9.75, subtract 2.55, gives me, oh boy, let's write out that whole number, 60.76388888. I'm willing to bet the 8 8's actually go on forever, but my calculator just rounded to this many decimal places. Cool. Now we need to do the exact same process again, but for the lower bound. Now for the lower bound, here's the good news. If I just swap all of these, that'll give me the lower bound. So if I take the smallest value of w, that'll make the value smaller, right? If I take the biggest value of a and the smallest value of c, that'll give me the lower bound. For the same reason, right? Because we want to make the denominator as big as possible, because as I make the denominator bigger, the value's getting smaller. And I'll make the numerator as small as possible, because as I make the numerator smaller, the overall value is getting smaller as well. So, lower bound of w, 432.5. Upper value of a, 9.85. Lower value of c, 2.45. So the good news is I can actually be quite clever and just go through and change a few digits and basically get the answer. 58.44 blah 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 blah. This kind of sucks because I didn't actually need to write out the whole thing at all. But if I compare these two numbers for a second, what's the most accurate value they both round to? So for example, if I round these to one decimal place, I'll get 60.8, 58.4. They're not the same value. But if I round them to 2SF, I'll get 61 and I'll get 60. So can you see how they're getting closer to each other? If I round it to 1SF, then I'll get 60 and 60. They'll both be the same thing. So these are the same numbers to one significant figure. Now, in all the other questions I've done, I haven't actually seen it be just 1SF. It's normally kind of like 1 decimal place or 2 decimal places. But the answer is 60. So t is equal to 60 to one significant figure. As the values do not change, they both round to 60. As the lower bound and upper bound round to 60 to 1SF. That means to a suitable degree of accuracy, t is 60 for 5 marks. Hopefully not too bad now. This question is actually quite short, so it's a cheeky little 3 marker, but when I read through it, and I've had some students kind of, the ones I tutor, when we've gone through it, it is something that causes a few issues because it is 3-dimensional something. 3D shapes tend to be a little bit trickier because it's harder to visualize, which I fully agree with. I had trouble with that when I was in school, but with a lot of practice you can get a lot better at it. So M is the midpoint of AB. Splendid. F is the point on MC such that MF to FC is 1 to 2. V is vertically above F, and they tell us that those 3 sides are all the same. Then they say that VF is 8, VCM is 52. In any geometry question, my first step, if they haven't done it already, and this includes vectors by the way, is I label the information. So VF is 8, so that's this length here, is 8. Then VCM, so that angle there, is 52 degrees. Now because that's a little tricky to see, I'm actually going to draw this 2D triangle, VFC. So if I draw that, VFC, because it's vertically above, this must be a right angle triangle. Because if I go straight up to the ground, I'm always at right angles. That is 8, and that's 52. The reason why I recommend you do this is because I think that once you've drawn out the triangle, and by the way, 3D trig and Pythagoras and all of that, it literally is just making right angle triangles. If you can do that, you're fine. Now that I see this, well, what could I work out? Well, I could work out VC, cool. I could work out CF, cool. Honestly, you would get a mark for just doing either one of those. So the thing is, if we look at what the actual question's asking, work out the side length of the equilateral triangle ABC. So if I draw ABC again, and this is an equilateral triangle, it's not bad. Well, if I look at FC, I can see that that's actually kind of relevant to what we're doing, isn't it? If you think about it, because FC is along the line CM. So if I work out FC, I can work out the height CM. And from that we can work out the side length by using either Pythagoras or trigonometry again. So again, that's how I build it. First of all is the information they give you, work out something with it. Work out everything you can with it. It generally gives you a mark, but it also gives you a hint on what the next step is. Now that I've drawn that out, if I look at what the question's asking me, the side length of ABC, well, I draw out ABC. That makes sense, right? Then they've given me this whole ratio. Well, okay, I'll draw that on my thing. Now it's really obvious what we have to do. We have to work out FC to work out the total height CM, so we can work out the side length. Now remember, in an equilateral triangle, all of the angles are 60. So we actually have that angle already. So let's get to it, shall we? Let's use, I don't know, purple. I like purple. We have FC is going to be our adjacent side. The opposite side is 8, and the hypotenuse is here. So we have O and A, so we're going to use tan. So we have tan 52 equals 8 over A. So A is just going to be 8 over tan 52. Again, calculator exam, so use a calculator, shockingly, I know. 8 over tan 52 gives us... Is that because I just didn't... There we go, okay. I've never seen my calculator reject me because of that, but fair enough. 6.25 centimetres, which means the whole length CM. Well, we've worked out F to C, this part, and that's worth 2 parts, and F to M is worth 1 part. So if 2 parts equals 6.25, the whole thing is going to be worth 3 parts, right? Because we've broken it up into 2 parts and 1 part. So if I go down to 1 part, then up to 3 parts, I just divide by 2, then times by 3. Which again, we have a calculator, so this is a little bit trivial. Divide by 2, times by 3, 9.38, let's call it. So again, now we know that length. I'm going to draw out that triangle again that we're using. We've got 9.38. Again, this is CMB. Cosmic microwave background radiation. 60 degrees. And we're working out the length C to B. So again, we use trig, same as usual. That's the opposite side. This is the adjacent side. This is the hypotenuse. So we're using O and H. So what do we use? We use sine. So we have sine 60 equals 9.38 over H. So then H is just going to be 9.38 over sine 60. There you go. Correct to 1 decimal place. Okay, so when I take that answer, divide it by sine 60. 10.8. That's it. So again, it's not too bad, but with 3D trig and Pythagoras, all you really want to do is draw out the separate triangles using the information they give you. Whatever information they give you, make a triangle out of it. Because there's a reason why they've given you the information, right? It's not completely useless. But, yeah, let's move on to the next question. Again, this one is, honestly, I think the big problem with even A-level and GCSE students is not using a diagram or not knowing how to draw a diagram. Because this question looks very difficult, and I would argue it's extremely difficult if you don't draw a diagram, as I've said like twice now. So, given that the angle PRQ, I can't read, is a right angle, find the possible values of K. Now that second to last sentence also scares students. Find the possible, wait, there's more than one answer, oh my god, oh my god, oh my god. Don't worry, chances are we'll get a quadratic and there's more than one answer, right? That's probably what's going to happen. I don't know, I haven't done it yet, but when I say draw a diagram, why am I saying to draw a diagram? Simple. Because it's telling you that one of the angles is a right angle. Now, the reason why that's important is it means that 2 of these lines, PQ, PR, QR, or whatever, or RQ, are perpendicular to each other. Which 2? Right? Now, some people can visualize things in their head, and, you know, God bless them. I wish them all the luck in the world. For me, I don't find that super easy. Now, if I draw out a right angle triangle, because I know it's going to be a right angle triangle, beautiful, it says PRQ is a right angle. So PRQ, the middle letter has to be where the right angle is, and then it's P and Q. Now we can easily see which 2 lengths are going to be perpendicular. If I tried to do PR and PQ, for example, I would not get the right answer because they're not perpendicular. If I did PQ and QR, nope, it's PR and RQ that are perpendicular. So PR, RQ are perpendicular. And that's the fact that we have to use in order to work out what the hell is going on over here. So, do I want to label the coordinates? Yeah, why not? Right? YOLO. And it doesn't have to be a super elaborate diagram. Like some people might want to use a coordinate axes and do all that fun stuff. You can if you want to, but the diagram is just there to help your brain visualize things. It's not there to actually give you any maths, if that makes sense. But when we have two lines that are perpendicular, what does it mean? It means that their gradients are negative reciprocals of each other. So if I work out the gradient of PR, which again is going to be some weird algebra, it's not going to be an actual answer. So k plus 3 minus 5, because it's change in y over change in x, over k minus minus 4. So why did I do it? Well, I've taken r minus p instead of p minus r. Simple. If I do 5 minus k plus 3, notice how I said it? It sounds like I'm saying 5 minus k plus 3, but what I mean is this, as in it would be a minus 3 as well. Which, again, a lot of students in the pressure of an exam will make that mistake. So I would always do the algebra minus the numbers because you're far less likely to make a mistake. So if I just quickly simplify this, that's going to be k minus 2 over k plus 4. Okay, and let's do the same thing with with QR. Almost immediately made a mistake. So QR, again, well, luckily we can do the algebra minus the letter again. So k plus 3 minus minus 6 over k minus 6. So that is k plus 9 over k minus 6. And like I said, these are negative reciprocals of each other. Why is that a good thing? Because then we're going to get an algebraic fraction, which is really, really nice and easy. So it doesn't matter which one I flip and which one I make negative, but one of them is going to be the negative reciprocal of the other. So let's do it so k plus 9 over k minus 6 equals the negative reciprocal, so I'm going to make that k plus 4 over k minus 2 now. If I expand this, which I would recommend because otherwise it's going to get a bit messy, all we need to do is times the numerator by minus 1, so it's minus k minus 4 over k minus 2. Now this is just an algebraic fraction question. That's it. So I'm going to cross multiply. So we get k plus 9, k minus 2 equals minus k minus 4, k minus 6. Trying to make this, there's a curve there. K times k is k squared. And then we have plus 9k minus 2k, so that's 7k. Then minus 14 equals minus k squared. Then we have plus 6k minus 4k, so that's 2k. Then we have plus 24. And I want to move everything over to the left-hand side. So we're going to add k squared to both sides, so I'll get 2k squared. Then I'm going to minus 2k from both sides, so I get 5k. Then I'm going to minus 24, so I get minus 36, equals 0. Now to solve this, we can use the quadratic formula, or we can factorize. If I factorize, that'll be times to minus 72 add to 5, which is doable, I suppose. But I think that might be a little bit annoying, right? Yeah. Instead, I might just use the quadratic formula. So, what do I want to do? Yeah, I think using the quadratic formula might be easier, or factorizing, whichever way you do it. In fact, I might just give you the factorizing, and I might give you the quadratic formula. So, if you were to factorize, your final answer would be what? K plus 6, 2k minus 7. No. Oh my god, I'm actually an idiot. Wait, minus 14 minus 24 is 38, not 32. Yeah, so that means that factorizing is actually slightly wrong. Let's just use the quadratic formula. Perfect. I've just noticed that's also 18, not... What the hell is wrong with me? It says 18 minus 18 minus 24. You know what, this is why you have to use a calculator for things. That is a bit shocking, that is. Anyways, let's move swiftly on. God, that's actually embarrassing. Minus 42 is what it should be. There we go. So it's going to be times to 84, add to 5. Now that makes a lot more sense. Okay, but let's use the quadratic formula anyway, just so I can show you that method as well. So if we sub it in, the quadratic formula is on your formula sheet. It's minus b, so minus 5 plus minus square root 5, because b squared, so 5 squared minus 4. A is 2, c is minus 42, over 2 times 2. Minus b plus minus, yeah, good. So we're going to get 3.5, perfect. Then all you need to do is change that to a negative sign. Get negative 6. There you go. Those are the potential values of k, and that's why it said values plural, because there are 2, right? Cool. Okay, so probability equations is a grade 9 topic, but again, I think it is something that a lot of students can get marks in, and it's not too bad. Because all you need to do is do the probability as if it had numbers, and then replace it with a letter. That's it. So there are only red and yellow counters in a box. 3/5 of the counters are red. Sophie takes at random 2 counters from the box. The probability that the counters are the same colour is 41 over 80. Work out the number of yellow counters. Okay. So they've given me this information here. Probability that they're the same colour. So the 2 possibilities are 2 reds or 2 yellows. So we're going to work out those probabilities and then add them, because both of those are valid ways, right? So we can either have 2 reds or 2 yellows. Now, because this is 3/5 of the counters are red, I might say that the total number of counters is 5x. Why? Because that's the denominator here. That means red is just 3x and yellow is 2x. Now, could you do this instead as a fraction? So for example, the total is x, red would be 3/5 x, yellow would be 2/5 x. Yes. The problem is I don't like fractions, so I'm not going to do it that way. So, using this information, what's the probability of getting 1 red? Well, remember that the probability of getting something is the number of that thing that you have over the total number. So, I like to say, okay, imagine there's 3 reds and 5 in total. You would write 3 over 5. But instead of 3 and 5, we have 3x and 5x. What the hell? 5x. So it's the same thing, right? That's it. Then that's times. Well, what happens when you take one out? Well, there's 1 less in there. So if there were 3 reds, there would now be 2 reds. So instead of 3x, we're going to have 3x minus 1. It's not going to be 2x, because we've minused 1. We haven't minused x. Over 5x minus 1. And I'm not even going to simplify that just yet, because I don't want to. And the probability of getting yellow, well, there's 2x yellows out of a total of 5x times 2x minus 1 over 5x minus 1. And what they're saying is if I add these 2 fractions, so what I might do is I might actually combine them very quickly. I'm not going to expand them yet though, because I think expanding towards the end might make a difference. It's just what I kind of personally prefer. By the way, you absolutely can cancel out the x on the top and bottom, and that would be basically the same thing, or at least a similar thing. And again, cancelling out the x. If I add those 2 fractions, apparently I should get 41 over 80. So let's see. So we have 3x minus 1 over 5x minus 1. Add 2x minus 1 over 5. That should be a 5 outside here as well. 5x minus 1 equals 41 over 80, and we have to solve for x. Okay. So first thing I would do is I would combine the fractions. So we have 3x minus 1, add 2x minus 1 over 5x minus 1 equals 41 over 80. I'm going to simplify the numerator. So we have 3 times 3x is 9x, plus 2 times 2x, 4x, so 9x plus 4x is 13x. Then we have 3 times minus 1, which is minus 3. 2 times minus 1, which is minus 2. Minus 3 minus 2 is minus 5. Over... yeah, I'll expand that, why not? 25x minus 5 equals 41 over 80. And basically, just like we did before, I'm going to cross multiply. So we get 80 times 13x. 80 times 13, well, that'll be 8. Actually, not. Why am I even doing it in my head, right? So 13 times 80 would be 1040x. Alright, 5 times 80, that would just be 400. That's nice and easy. 41 times 25. 1025x. Minus, so that'd be 410, 205. 205. I want to move the x's to this side and the numbers to this side. So 1040x minus 1025x would be 15x, because that's just 40 minus 25. Minus 205 plus 400 would be 195. Yes. Which means x is 195 divided by 15. See how quick this was now, now that we don't have any fractions? But yeah, that's 13. So if x is 13, then the number of yellow counters is 2x. So that's also a really important thing, by the way. I've seen some students not actually answer the question, so they'll work out like x or something, but that's not what the question's asking for. That's what it's asking for. And there we go. I think those were the hardest questions from paper 2. Obviously we have paper 3 to do as well, but hopefully you found that quite useful. Some of those questions were a bit weird, a little bit different. If you notice, the maths is very similar, right? Like trigonometry you all know how to do, fractions you all know how to do, gradients you know how to do. It's just the context they put them in. The best way to improve context is to try these hard questions. If you get stuck, then obviously watch your videos or ask your teachers or whatever to get some help on it. But that's how you improve in maths. It's just how you apply it more than actually knowing how to do it. But anything you don't know how to do, that's where you should go off and revise, then try and apply it. If you did find any of this useful, then please do consider subscribing. It does help me out. But I'll leave you to your revision. Best of luck, and see you in the next one.